talking about is U-substitution. U-substitution happens to be another way to find what integrals are equal to find antiderivatives, and, well, ultimately just become really, really good at integrating. I'm thinking about planning, excuse me, something called an integration bee in May after the AP test. You guys are all familiar with spelling bees, right?
Yeah.
Okay. So there's sort of a calculus, not really tradition because not every calc class does it, but there's something called an integration bee that's like a spelling bee, except it's a head-to-head direct integration challenge between students. And it was fun. I placed, I didn't even get into the integration bee when I was a junior, but when I was a senior, I won. All right. I'm going to start out with this question right here. That is the function f of x. And what I want to know is what's f prime of x. And we've sort of talked about this, well, just a few minutes ago. What's f prime of x equal to? What do you guys remember? So cosine of x squared times 2x. Where'd the 2x come from again?
Chain rule.
Deriving the inside, the chain rule, exactly. And the chain rule was used. You see, the reason why I'm starting with this is because we'll be finding antiderivatives. And you guys should, well, so far you know the anti-power rule, like the reverse power rule. That's how you have been taking antiderivatives for the last week. But for every single derivative rule, there is an anti-derivative rule associated with it. So, you know the product rule? Well, guess what? There's an anti-product rule. There's also an anti-quotient rule. Will we be doing that? No, we will not. And we'll not be doing the anti-product rule either, because believe it or not, that's actually fairly difficult. It's left for something in Calc 2. We might cover it after the AP in May. Actually, we probably will cover it. It's good to know, because a good portion of you will be going on to Calc 2. All right. Now, here's the next question I want to ask. What's the integral of cosine of x squared 2x? The integral of 2x times cosine of x squared. Jack says that this is equal to sine of x squared. Plus c. The times 2x was for doing the chain rule, but we're forgetting the plus c here. Hopefully, this should be relatively obvious because did we just find the derivative of sine of x squared? Like just before this? We just did before this. And what is the integral telling us to do with 2x cosine of x squared? Find the antiderivative. Are there questions right now? Okay. All right. What we'll be looking for when we do integrals that happen to deal with U-substitution that are the anti-chain rule, you have to keep in mind not only what's the antiderivative, but you have to keep in mind also like what's the derivative and where does it fit in. It sounds a little bit strange, but you'll see what I mean in a second. So we're going to do this same problem, but with U-substitution. Okay? Now the rules of U-substitution go like this. I'll write some steps off to the side. So we already know what this antiderivative is equal to, and that means that this will be a prime example to actually learn how U-substitution works in a way where we already know what we should get in the end. So thing number one, for U-substitution, what you will want to do is pick a U. So pick a U.
So you're like repeating stuff back here?
Oh. Is that what's annoying? Yes. My apologies. I'm sorry, I didn't know that was happening. Okay. So pick a U is the first thing that you'll want to do. And in order to pick a U, you'll want to make sure that you see a U prime somewhere. So here's what we're going to do. The U that I'm going to pick in this integral is x squared. You can pick any, this is called the integrand, the inside of the integral. And yes, we can pick any part of it that we want. So you can pick any part of the integrand that you want. Will some things that you pick just straight up not work? Yes. That's why you want to be careful to look for the U prime, look for the du in the integral. Then you'll start to know what's going to work and what's not. You get good at U-substitution through basically practice. This is pattern recognition is what it is. And at this stage, you guys will get awesome at it. But when we start to add in more functions like ln of x and e to the x and 2 to the x and things of that nature, then it becomes a little more difficult to keep everything straight. But we're going to be really good. I'm going to calculate over here my derivative of u, du over dx. What's du over dx equal to? 2x. Okay, 2x, just the derivative. Do you guys see 2x somewhere in this integrand? Okay, that's what you're looking for when I see the parentheses in step 1. Make sure you see a u prime. Now step 2 is where things start to come together. I want you to solve for dx. So when I solve for dx, I'm going to multiply the dx over the other side. And we get du equals 2x dx, right? And then to get dx by itself, I would just divide 2x over the other side. So essentially we get du over 2x. The point of this is probably a little strange right now, but do you have any questions? Sounds good. Let's keep going. Now, what we do is we substitute. Substitute and cancel. All right. So this integral becomes 2x times cosine. Cosine of what? Instead of x squared, what did we say x squared was equal to? U. I'm going to write cosine of u right there. That's why it's called U-substitution. You are subbing a variable in for a part of this that will make this integral look simpler to you and thus able to derive. So u times, and then what was dx equal to, according to our substitution? Du over 2x. Apologize, I overlapped a little bit there. But dx is du over 2x. And then the x squared was u. Now the whole point of this, look at this 2x and look at that 2x.
Cancel out.
When you times them, they do what?
Cancel out.
They cancel out. You guys see that in this integral? Everything is multiplied together, and the 2x's will cancel out because of that. And then this integral turns into the integral of what?
Cosine of u times du.
Cosine of u times du. Maybe you remember when we first talked about definite and indefinite integrals, and I said the dx is important. Write it at the end of your integrals. It means something. It needs to be there. This process is why you need to be aware of the existence of dx, why it's important, because when you change things to du, it's not just a simple, like changing x's to u's. You actually have to cancel things out and substitute things in. It's a critical part of each integral, because we know how to find the integral of cosine of u du. What is this integral equal to? Sine of u. The variables are u in this integral now. So when we integrate it, it's just sine of u du. We did the antiderivative, sine of u plus c.
Wait, wouldn't it be negative for your answer?
And then in this problem, did I start with u's or did I start with x's? Started with x's. So instead of that u right there, I should resub back in my x's, and I get that the antiderivative is actually sine of what? Yeah, sine of x squared. Let's see. Sorry, JC? So here we go. That is our final antiderivative. Kaylee.
You said at the beginning how you just pick a u, so what if you pick like 4 and you do all that work and it doesn't?
You'll know almost right away when you start doing the work that something isn't going to happen. And this will be really quick. The first example always goes slow, but you'll quickly see when you start solving for dx that things don't cancel out. And if nothing cancels out, then you pick the wrong one. But you will get good at picking u's. I promise you that, especially at this early stage.
Okay.
What are your other questions?
Is this something that like happens in the background? Like we've been doing it, but haven't been realizing it?
What do you mean?
Well, like we can get the answer the 2x cosine of x squared by just doing like what we've been doing lately. Like you just sum it out and you get sine of x squared. But we do all that and we get the same answer.
So you're saying that you think you could have found that antiderivative before today?
Yeah, we could we?
Well, if you did, because a lot of you guys, if you did the anti-power rule, might write something like x squared and then sine of x squared, which is not actually the antiderivative to that. And then you might say, okay, well then what if we just do, like we just try some things and then we'll get it in the end. You're right, I think you could get the antiderivative if you essentially do guess and check. But that's kind of an inefficient method, especially when we start to see things that are more complicated than this. U-substitution is a really handy thing because it gets you to the right antiderivative every time, as long as you pick a u that makes sense in the problem. But are you correct? Could you just guess and check and derive what you're guessing to see if it works? You absolutely could, yeah. Let's take a look at the next example right here, which is very similar. And you guys should have this in your notes. Or is it written down in there? No, it's not. Okay, could you please write it down in there? I'm going to bop between a few examples here because I want to be quick so you guys have a chance to do this on your own. All right. Let's pick a u. So if we pick u equals 6x squared, let's see what would happen. If u equals 6x squared, then I find du over dx. And I would get, okay, what's du over dx here? What's that? 12x. And then dx, if I were to solve for it, I multiply it over, I divide by 12x, I'd get du over 12x. So if I plugged in u for that, and then I said dx was du over 12x, does anything cancel out? Really? It, like something shouldn't feel right about this particular u substitution. So thank you for bringing that up. but anyone have a different idea for picking a u? X cubed. Why do you pick x cubed? Is there a sense that you have about that?
Because when you derive x cubed, you get 3x squared, and which is just a multiple of 6x.
When you derive x cubed, you get 3x squared, which is very close to 6x squared. Maybe something will cancel out with that. So let's try this. So u equals x cubed, and then can anyone think they can tell me just straight up what's dx equal to?
Du over 3x squared.
Yeah. du divided by 3x squared. I actually used to teach U-Substitution differently the last 4 years. This is a method that I learned just about a month ago, and it's really, really slick. I like it quite a bit. Kaylee.
Is that like the right answer, or would you want like 2x cubed, so then it would completely cancel out?
Great question. You will see what happens, how we deal with the fact that this isn't quite equal to 6x squared in just a minute. Okay. I want you guys to go through and sub in the things into this integral. So can you rewrite this integral with the u's and the dx subbed in? Should be getting something like this. The integral of, we have nothing to sub in for 6x squared, so it's just 6x squared, times cosine, and what are we subbing in for x cubed? U? And then, what is dx equal to? du over 3x squared. Does something cancel out? We'd be left with the 2. The x squareds would go away for sure, but then we'd have 6 divided by 3, which is just what? 2. So here's what you do. Because you're left with 6 over 3, which is 2, you just take that 2 and take it outside of the integral. It's a constant, and you can use the multiply by a constant property. Pull it outside. And then you're left with cosine of u times what? du. Yeah, du's and dx's are definite parts of our integrals. We want them to be there. They tell us information, what variable we are anti-deriving with respect to. What's the antiderivative of cosine of u? Sine of u. So 2 times sine of u. Plus c, okay. You don't need the du anymore, because that together with the du just mean to anti-derive. It's a verb. We anti-derived. Is this our final answer though? What do we have to do? We have to plug in the x cubed. It started with x's, we better end with x's. So 2 sine of x cubed plus c. What was the point of it? To help us actually get it to a form that was familiar to us. So does this integral look easy to us right there, the way that it is? No. But by putting the u's in there, does this integral look much easier to anti-derive? So the point of U-substitution, you're not actually changing the problem at all. What you're doing is you're rewriting it so that it looks more familiar to you, more recognizable. You know the antiderivative of cosine, that's easy, it's sine. You don't really know as well what the antiderivative of 6x squared cosine of x cubed is. That's a little bit more difficult. So we just make a variable swap to make things easier on us.
So then we can use the equation or whatever we end up with to find integral, the original equation.
derived this, you would end up with 6x squared cosine of x cubed. Okay.
So that question that I asked earlier, if you were to use 6x or 2x cubed right away, wouldn't you not have a 2 then anymore?
So what's difficult about that is that if you were to use 2x cubed, then you'd have to multiply this u by 1/2 to make it fit into that x cubed right there. And then you'd have cosine of 1/2 u, which would make the problem slightly different. It's hard to explain just like when I'm up here in words. If you want to, we can touch base afterwards. But yeah, it just makes things difficult. I'd rather you pick based on the u and then just adjust the dx to make things fit, rather than trying to make the u fit the. Okay, yeah. All right, let's take a look at this, guys. Evaluate the integral. Got x to the 4th plus 4 to the 11th times x cubed.
That would be the same.
As you're writing this down, could you do this without U-substitution? You could. It would take a lot of work. What work would it take to do this without U-substitution? Oh no, it wouldn't take less work. We'd have to not distribute.
Well, you'd have to multiply times yourself 11 times.
You'd have to multiply x to the 4th. You'd have to FOIL x to the 4th plus 4 out 11 times. You'd have to FOIL 11 times. Does that sound like a fun proposition? No. It would take about an hour to do that. And then you'd have to multiply everything by x cubed afterwards. That would be the way you use the reverse power rule. Much better to use the chain rule. Now, I will say that on my tests and the AP, these problems can get tricky because sometimes what they'll do is they won't do the 11th power. When you do the 11th power in the problem like this, it's very clear that you're not supposed to multiply that out because that would be very painful. Sometimes, though, they will make the power just small enough so you will be tempted to multiply it out. Think cubed instead of to the 11th power. A cubed is much more reasonable to multiply out. You might be tempted to do that. Don't. Look for U-substitution.
So how can you know when you're supposed to use this?
That's a very good question. And I know it seems like a cop-out answer, but it's basically just experience. You learn to recognize the patterns. When I look at this, I see something of, oh, there's an inside. Oh, and the inside has like its derivative outside of it. That's a U-substitution problem to me. And you'll start to recognize like the inside and the derivatives when you look at more of these integrals. So what do you guys think? What would be a good U to pick in this problem? If we picked x cubed, what would the derivative of that be? 3x squared. Do you see a 3x squared anywhere in this?
No.
Okay. So
Would be
x to the 4th. So if we picked x to the 4th, what's the derivative of x to the 4th?
4x.
Do you see anything like 4x cubed? Yeah, you should see an x cubed, right? Now, I'm going to make a slight adjustment to what JC picked. He said x to the 4th. Is there any, what's the opposite of benefit? Why can't I think of this word? Is there any disadvantage to doing this for you?
No.
Yeah, why not just take the plus 4 along for the ride? Because when we derive x to the 4th plus 4, what happens to the 4th? It gets destroyed. Take it along for the ride. Have fun. So dx equals, what's dx going to be equal to? Du over not x to the 4th plus 4? The derivative of it. Yeah, because it's technically du over dx, then we're solving for dx. So this would be 4x cubed. All right, I want you guys to sub in and see if you can integrate from here. Okay, so take a minute or two and just see what you can make of this. right along. I'm just going to sub in first, and then if you want to keep going, go ahead. But when I sub in here, I would get u to the 11th, and then times x cubed times, and then dx is du over 4x cubed.
Well, you have to have plus 4 in there to the 11.
No.
Or what to be u to the 4th plus 4 to the 11th.
So what you're asking is you're saying, okay, u is x, but what did we say u was equal to?
X. Oh, okay.
So this whole thing right there, that is our u. Good question. And then at this point, how many people were able to rewrite it here? Okay, what happens?
X cubed cancels out.
X cubed cancels out, bada bing, bada boom. X cubed completely cancels out and leaves behind 1/4. The 4 is in the bottom of the fraction, so 1/4 is left behind. And we can then pull the 1/4 out front of the integral, because it's just a constant, we can pull it outside. And we're left with, what's left inside the integral? U to the 11th du. Okay. And now we antiderive. Guys, what's the antiderivative of u to the 11th?
11 u to the 12.
That's the derivative. Go backwards instead. Go up. So it's 1/12 u to the 12th plus c. And what did this have in front of it?
1/4.
1/4. So in the end,
Would it be parentheses
parentheses where?
around 1/12?
I mean, you could. So JC's asking, wouldn't there be parentheses around this whole thing? Yes, there technically would be. And then if we distributed the 1/4 to the c, we would still just have a number, right? So we can effectively just keep it as plus c, like that. The plus c is kind of a weird thing. A lot of times you just write c because no matter what, you multiply it by 1/4, you add whatever. It just is a number. And then this ends up being 148. And then what was u? X to the 4th plus 4, and then plus c. And there's our antiderivative.
That's our
Yep, because we antiderived from u to the 11th up to u to the 12th. This is, sorry?
Where did you go?
Got the 12.
That was the
Oh.
12.
My apologies. U to the 12th. There we go. Is that why you thought it maybe wasn't the antiderivative? Okay, no problem. So I want you guys to remember, if we were to derive this right here, we would get what we started with. You'd have to use the chain rule. What's the derivative of the inside here? 4x to the 3rd, and then that would multiply outside. And then the 12 would come down, and together those things would sort of cancel out and make, well, nothing in front. And you'd have x cubed and then the 11th power. If you derived this using the chain rule, that's what you'd get. Okay. What we might do is do one more example tomorrow, but right now I just want to let you guys take a look at the first few problems. This seems weird right now, I know that. But this will only get easier as you go along. As a matter of fact, you'll actually start to like it afterwards. Maybe I shouldn't have said that. But okay, let me know what questions you guys have as you have